Hey everyone, I hope you and all your families are doing well. Just wanted to go over and kind of go through the assignment that I gave you on Wednesday in case you guys wanted to look through this. And it's a YouTube link, so like I said before in that post, you guys can skip ahead, go back, and just really look at whatever problem that you need to look at. All right, so the first one we're going to start with is number one. So I know we had a big focus on this homework of using that Pythagorean identity to substitute in so that we can get every single trig function the same. So when we're going to use that is on problems like 1, 2, and 3, where you see that you have different trig functions going on in that same equation. So in this case, like on number 1, you have a sine squared and a cosine. So because that sine is squared, that allows you to use that Pythagorean identity to rewrite that. So we know that we rearranged it before in those notes. So I can plug in a 1 minus cosine squared for that sine squared. I'm still going to have that 2 out in front. And then we still have our minus 3 cosine x, and it's equal to 0. All right, so that first step was just plugging in using that identity. After you guys plug in, now we want to start maybe condensing this left side of the equal sign. So let's try to distribute this 2 inside. We end up with 2 minus 2 times cosine squared x, and we still have our minus 3 cosine x, and this is equal to 0. All right, so at this step, now that you guys see you have a cosine squared, a cosine of the first, and then this term all the way to the left that doesn't have a cosine with it, you want to rearrange this to have that cosine squared out in front because you're probably going to have to factor to solve this problem. Make sure that 2 that you move to the back just stays positive. All right, so now once you guys are here, like we said, we always want that first term to be positive. It just makes it a lot easier to factor. So we can go through and multiply everything by -1. And all it really does is changes each one of the signs. So it ends up looking like this. All right. All right, so now this is something that we know we can factor. Just be careful with this 2 out in front right here. So when you guys go to factor this and you break this up into your sets of 2 groups, you're definitely going to start each group with a cosine x, but that 2 has to be in front of one of them. So one of them is going to be 2 cosine x. The other one's just going to be cosine x. If I need to get 3, we know we can do 2 times 2 to get 4. On the inside, 1 times 1, that gives us 1. The 3 is positive. This has got to be a positive. This has got to be a negative. All right. All right, so then each one of these 2 groups, we set them equal to 0 to solve. So on my left-hand side, we end up getting cosine x is equal to a positive 1/2. And on the right side, you end up getting cosine x is equal to a -2. All right, so let's start with this right side because I think it's going to be a little bit easier. When you guys end up with cosine x is equal to -2, that looks like a non-special angle. So when you go through and try to do the inverse of cosine and plug in a 2, you should end up getting an error message on your calculator, which tells us that we actually can't find our answer for x on that right side at all. So we're really just going to focus on this left side being cosine x is equal to a 1/2. All right, I'm going to do it a little bit over here and then erase it later, just kind of give myself room. But when you guys have cosine x is equal to 1/2, remember, think about first, is this a special or non-special? 1/2 is definitely something that looks familiar. So we're really thinking about, in this case, since we have cosine, we're thinking about where x is 1/2. And we know x is 1/2 with the special angle of pi over 3. And then we also want to think about the quadrants that we're in. And we're also, since we know that this 1/2 is really positive, we're thinking about where x is positive, which is in quadrant 1 and quadrant 4. So using pi over 3 to get to quadrant 1 and quadrant 4, our 2 answers for x would then be pi over 3 in quadrant 1 and then 5 pi over 3 in quadrant 4. So that's how you guys would get your 2 different answers. All right, I'm going to go through and erase this just so I have enough room to do problem number 2. And I'll just erase some of this. All right, that should be fine. All right. All right, so when you look at number two is really similar to number one, where if you look, you have two different trig functions going on. So that tells you that you want to use your identity to try to plug in for one of them. So since I see this cosine is to the first and this sine here is to the second, I'm going to want to plug in for that sine squared. So we're going to do the same thing we did on number one. That 2 is going to stay out in front. I'm going to use my 1 minus cosine squared x to plug in for sine squared. We still have our minus cosine x. In this case, we have a minus 2, and it's equal to 0. So let's try to condense this left side a little bit. If we distribute the 2 inside, all right, that's what we would end up with. Then from this point, we try to combine some like terms. Now, if you looked at my answer key, when you guys combine your like terms, the 2 and the negative 2 will cancel. So that just leaves you with a negative 2 cosine squared x minus cosine x, and that's equal to 0. All right, so now once you're at this step, same thing like we did on number one is we want to try to factor, but you can't factor it like you did with number one and break it down into parentheses because this is only 2 terms, not 3. So when we factor, the only thing that we can really do, excuse me, at this point is take out a GCF. So you guys can take out, I like to take out a negative, especially when I see that first term is negative. You can take out a negative cosine of x, and that leaves you with a positive 2 cosine of x. And when you take a negative cosine of x away from a negative cosine of x, you're just left with a positive 1. And then that's equal to 0. So then same thing here. You want to set the left group, which is just, let me switch a color. So you want to set your GCF and also what you have left over, both equal to 0 and solve to then eventually get x by itself. So then if I set negative cosine x equal to 0, I just end up getting cosine x is equal to 0. This right group would end up giving me cosine x is equal to a negative 1/2. All right, let me move down, see if I can maybe get a little bit of room. All right, so now once you guys are here, if you look at the left side is actually a special angle because what it's telling us is since we're working with cosine, it's saying, all right, we need to figure out where x is 0. And if we think about our special angles, x is going to be 0 on one of our or two of our axes, right? We know we get an x value of 0 at our positive y and our negative y axis. So when we start to write our final answers, which you know what, maybe I'll write them down here. We end up getting 2 angles first as a pi over 2 and 3 pi over 2. All right, so that's from the left side. Now, if you look at the right side, all right, we kind of talked about this similar to problem number 1, but if cosine x is equal to negative 1/2, that means, again, that x is really 1/2. So we know that we're working with a special angle, again, of pi over 3, but since that 1/2 is now negative, we know in this case that we're in quadrant number 2 and quadrant number 3 because that gives us a negative x value. So using that pi over 3, we would end up getting 2 pi over 3 is in quadrant 2. And then also 4 pi over 3 would be in quadrant number 3. And this would be your 4 answers for number 2. All right, so let's go on to number 3. So obviously got to erase some of this stuff. All right, so when you guys look at that third problem, again, I know this is really similar to problem number 1 and 2, but just to point out one more time, if you guys are seeing that sine and cosine, like 2 different trig functions in your equation, just make sure you use your identity to plug in. So we can again use that sine squared and plug in a 1 minus cosine squared. But we're still going to have our plus 5 cosine x and our minus 4. And that's equal to 0. Same thing we've been doing. Let's take that 2 and distribute that inside. And then start combining some like terms, which we can really just combine the 2 and the negative 4 together. That'll give us a negative 2 at the end. And then again, since our lead term is negative, we just want to go through and flip all of our signs. All right, so you end up looking with 2 cosine squared x minus 5 cosine x plus 2 is equal to 0. All right, so at this point, you want to try to factor 2. Now, I know we kind of pointed this out earlier, but especially when there's a number in front of that cosine squared, just be really careful because that number is going to play a big part in how you factor this thing. So when we go to factor, we're going to have a 2 cosine x and then just a cosine x. And if we're trying to get a negative 5, put that at the end, you see a plus 2. We're going to use our factors of 2. And in this case, both of our signs have to be negative. All right, so then same thing that we've done before. You want to take both the left and the right group and solve for cosine. So this is going to give us cosine x is equal to a 1/2 on the left. For the right group, we're going to end up getting a cosine x is equal to a positive 2. All right, so really similar. All right, this, if you guys notice, that's a non-special, but if you try to find the inverse of that to get a reference angle, it's going to give you an error message, so that one doesn't actually work. Our left group, we know that we're working with the special angle of pi over 3 again. We know since 1/2 is positive, you guys are going to be in quadrant number 1 and quadrant number 4. So that means in this case, your answer, or I should say your answers or solutions, are going to be pi over 3 and 5 pi over 3. And those would be your two values. All right, so problems 1 and 3 all worked with obviously using that Pythagorean identity, that trig identity, to try to plug in to get all of your trig functions the same. And then you can go through and solve for x from there. Numbers 4 and 5 was a little bit more review of special and non-special angles. But I thought they were good, especially like number 4, because instead of just having sine or cosine, you had to actually work with a cosecant instead. Actually, on this one, it's kind of good when we're going over this, because looking at some of your guys' answers, I actually noticed a mistake on my answer key. So on my answer key, I had number 4 only having 2 solutions of pi over 3 and 2 pi over 3, but this one ended up actually having 4 solutions, and I'll kind of explain why as we get there. All right, but on number 4, you have 3 cosecant squared x minus 4 is equal to 0. So the first thing that we talk about always is trying to get whatever trig function it is by itself. Now, on a lot of these other problems, we saw like 2 trig functions happening, so we had to maybe try to factor or substitute in. But in this case, on number 4, you just have that 1 cosecant squared x. So what we can do is we can add 4 and then divide by 3 to start getting this cosecant squared x by itself. So that would end up giving us, when we add 4 and divide by 3, cosecant squared x is equal to 4/3. Now, here's the mistake I made. At this point, you definitely want to take the square root because you want to get cosecant by itself and not just cosecant squared. So when you do that, anytime we take a square root, you always have that plus minus sign out in front. And that plus minus sign is what I forgot on my answer key. The square root of 4 is 2. And the square root of 3 is, well, we just have to leave that at root 3. All right, now when you guys are at this point, I know a lot of you started to like multiply the bottom and top by root 3 to get rid of that root 3 on the bottom. But before you do that, focus on what you have on this left-hand side. Since you're working with cosecant, remember, we always want to make like secant or cosecant and like flip it and make it either sine or cosine. So we know that cosecant goes with sine. So what we can just do is we can flip cosecant and just make that into sine of x. But if you flip that, that just means that you're going to have to flip the right-hand side too. So instead of 2 over root 3, we end up with root 3 over 2, which actually helps us out because now at this point, you guys are aware, like this is something that you know how to solve. Sine we know goes with y, and since we're saying that y is equal to root 3 over 2, that means we really know we're working with the special angle of pi over 3 again. And since we see that we have a plus minus, again, and here's my mistake, that plus minus, we're really saying that sine has to be positive or negative, which is why that we end up in all 4 quadrants. So once we end up in all 4 quadrants using pi over 3, we end up getting our solutions of pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All right, so those were all of your 4 solutions for problem number 4. Again, I apologize on my answer key. I made a mistake, so there should be 4 solutions, not just 2. All right, last one we're going to go over. Last one we'll talk about is number 5. So on number 5, you have 3 tangent squared x plus 4 tangent x minus 4 is equal to 0. So on this one, since you guys are looking at this equation and you see that you have tangent squared and just a tangent, you don't need to plug in with any identity because those trig functions are the exact same. The only thing that you really need to look to do is just try to factor this problem. So when we go through and factor, again, just kind of pay attention to that 3 out in front, but you can't take out a greatest common factor. So you're going to have to break it up into 2 sets of parentheses. The 3 is going to have to be in front of one of the tangents. So we're looking at our factors of 3 with our factors of this 4 at the end to try to add together to give you that 4 in the middle. So what we're going to do is 3 times 2 gives us 6. 2 times 1 gives us 2. The 4's got to be positive, so that 2 is going to be positive, and this 2 right here is going to be negative. All right, so if we now have our 2 different groups, let's set both of those groups equal to 0 and solve. So on the left-hand side, we're going to end up getting that tangent of x is equal to 2/3. And then for that right group, we end up getting tangent of x is equal to a negative 2. All right, so once you guys are here, now that you're working with tangent, you have to recognize at this point that 2/3 and negative 2, they are not special angles. So what you're going to have to do is use your calculator to then find those reference angles and then figure out the quadrants and get your final answers from there. All right, so if we look at our left side first, when we go through and find this reference angle, remember you're putting the inverse of tangent of 2/3 in your calculator. So let me, actually, you know what, I'll write that out. So you have the inverse of tangent of 2/3. And if you guys need any help using your calculators or using Desmos, just let me know and I'd be more than happy to help you out. So now we have tangent, the inverse of tangent 2/3. That gives us our reference angle, which in this case, we end up getting a 0.588. If we think about the quadrants that we're in, since that 2/3 is positive, we know tangent is positive in quadrant number 1 and quadrant number 3. I was trying to get rid of this, but I don't know if I can. All right, so that means when we go through and we find our answers, quadrant number 1 using our reference angle, we're going to get 0.588. And then quadrant number 3, remember we have to, since we're in quadrant 3, our closest x-axis is pi, so all we have to do is take 0.588 and add that to pi to get to quadrant 3, which ended up being 3.730. All right, so those were your 2 answers from your left side. Now we have to do the same exact thing on the right side. So when you guys have tangent of x is equal to negative 2, just again, be careful. Make sure when you're finding that reference angle, you're not going to input a negative. Keep it positive. So in your calculator, you should do the inverse of tangent of a positive 2. And that's going to give you a reference angle of 1.107. So now that you have that, the negative 2 up top just helps you figure out your quadrants. Because since we know that tangent of x is equal to a negative 2, we're saying that tangent is negative, and tangent is negative in quadrant number 2 and quadrant number 4. So then to get to quadrant 2, kind of similar like how we talked about getting to quadrant 3 on that the left side. To get to quadrant number 2, your closest x-axis here is pi. So you have to take pi and subtract 1.107 from it because you're going backwards to get to quadrant 2. So that would end up giving us 2.035. And then our last answer that we have to get is in quadrant 4. So similar to what we just talked about in quadrant 2, your closest x-axis to quadrant 4 is actually 2 pi. So what you're going to have to do is take 2 pi and subtract 1.107 from it, and that's going to give you the value of 5.176. So sorry, I know it's kind of sloppy down here, but this would be your 4 final answers for this problem. So like I said, guys, if there's anything I went over maybe a little bit too quick, too fast, or you need help using your calculators, or any help at all, join that Google Meet session later today, or email me, ask me any questions, and I'd be more than happy to help you guys out. All right, I hope you guys have a good rest of your day, and have a great weekend.